Welcome to part 3 of restoring and updating this Boxford TCL 160. In the first part we looked at the mechanical issues, we tied up all the rust, we gave it a coat of paint. In the second-ish part of the series we looked at the electronics layout, and today we're looking at motors and drives. So we've got three motors and drives on here. We've got the Z-axis, the X-axis, and then we've got the spindle drive and controlling that. So that's what we're going to focus on today. So the stepper motors just have flying leads, so I've made a little bracket here, Loctite at the top, and just tidied these up so that there's not strain on the flying leads as it enters the motor. So if we focus on the X and Z axis first, you can see we've got the breakout board. This has got the 25 pin connection, the USB connection for 5 volts, and then I've taken the 36 volt through a rectifier and regulator circuit board. The rectifier bit's pretty redundant, but this regulates it down to 24 volts, which goes in here. So that supplies the breakout board. The breakout board is then connected to the 2 stepper drivers. So we've got 5 volt power, we've got the enable signal, and then we've got the step and direction of the 2 drives. So they're connected into these drivers. These drivers are powered by the 36 volt power supply. So there's a power supply that comes in here, bridges across. There's also the 5 volt connection, as I said, to the breakout board, and we have the step and the direction, and then we have the 4 high voltage wires that go to the stepper motors. So these 4 high voltage wires on both the X and the Z axis, these go up to the stepper motors. So I'm running Mach 3 on an old Pentium 4 that I got off eBay. My previous machine, the power supply died, so I've bought exactly the same machine and just reloaded Mach 3. So I've set up a profile for the lathe. So let's open that up now. And the lathe, as you can probably hear, is on. So we'll just reset the emergency stop. There aren't actually any emergency stop buttons wired in yet. That's for the next episode of the rebuild. But let's set up, or at least have a look at the setup for the machine. So I've set this up as a metric machine. That's generally what I'm used to using, though half my machines are imperial. Ports and pins then, so set a standard for the 25 kilohertz. Port 1's enabled. So if we look at the motor outputs, we've got 3 motor outputs enabled. The X-axis and the step and direction pin are as per the breakout board details. The Z-axis, again, step and direction pin as per the breakout board, and then the spindle, the step pin, which is what controls the speed of the spindle, is set up at 1. The direction low active is not selected for these, apart from I discovered by chance that I needed to select that for the spindle for it to work, and then the port is number 1. So that's set up fairly straightforwardly. Input signals, as yet there aren't any input signals. As said, the next episode we'll be putting homing switches on, as well as setting the emergency stops and the input signal from the slotted disc on the back of the spindle. Output signals then, we've got enable, which is pin number 14 on the breakout board that I've got, and output 1 is for the main drive spindle. So on that breakout board, that's pin number 17. That's something that wasn't really that clear in the documentation, so I had to do a bit of digging around, and I'll show you a little bit more detail on that later on when we look at the spindle drive. And at the moment we haven't got anything else selected there. Nothing selected for encoder or MPGs at the moment. And then the spindle, I've selected to use spindle output motor, PMW control. I've very arbitrarily set the base frequency at 500 and the minimum pulse width modulation 0%. Okay, so that's a very quick run round the setup. Just very quickly, we'll jog the machine. Sorry, I'm in the way. So if we jog the Z, you can see that that's operating fine, and we can do the same with the X. So as yet, I haven't tuned the motor, so if we go into motor tuning, and we'll look at the X-axis just for example. This is a fairly standard arbitrary setup, and I need to do that. So my understanding is the lead screws on this are 2mm pitch. I think there's a ratio of about either 12 or 16 to 20 on the motor pulleys. And the motors are 200 steps per revolution, and I will set them for 10 times micro stepping. So we need to set these up, but for the time being it's sufficient to run the machine just to jog the axis around, make sure everything's operating. So if we have another quick look at the config menu, so we've been through native units, ports and pins. We'll look at motor tuning at some other time in more detail. Homing and limits we'll look in more detail some other time. But now let's look at spindle pulleys. So I've got 4 spindle pulleys set up in this. Spindle pulley number 1, max speed 596 and a ratio of 9.3 to the motor. Number 2, 1192, max speed, ratio of 4.6 to the motor. 3, maximum speed 2385 and a ratio of 2.3 to the motor. And then spindle number 4, max speed 4759 and a ratio of 1.2 to the motor. I haven't set a min speed for any of these. I might do in the future, but I don't think this motor has an issue at running at low speed, as long as not too much power or torque is expected of it. So they're now set up, so we'll set it up for pulley number 4, because that's what it's actually set at in the back of the machine. And now we can operate the spindle. So if we what I will do is type in a desired speed. So let's type in 4000. Okay. And then we'll start the spindle. You might just be able to hear, and you can see the spindle spinning up there just in the corner of the shop. You can certainly hear it. So we can drop that down. So this is working nearly properly. There's an issue that I'll show you when we get in the back of the machine again, and how I've set that spindle control up, and there's something I do need to resolve in there. So let's stop that spindle now. So as I showed in the previous video, we're driving the DC motor with this DC motor drive that I got off AliExpress. So the motor is connected with these 2 high voltage connections. Into the motor controller we have the mains voltage, we have an enable, or an inhibit should I say, connection to the breakout board, and then we've got a 0 to 10 volts and earth from the breakout board. And what I've done is I've put a potential divider in here to drop that down to, or in theory to drop it to the 5 volts that this control board or this control unit needs to operate, because originally I had a sort of potentiometer control, as you saw in the previous video. So they're routed through this bit of trunking, and they're routed to the breakout board. So you can see we've got the, let's get out of the way. we've got the inhibit into the relay connection of the breakout board, and then we've got the 0 to 10 volts plugged in here. This is pin number 17 this is connected to, and there's a brake or a jumper here that can be configured to either drive the spindle control on pin number 17, or the spindle relay on pin number 17, or be used for a B axis. So that at the moment is set for pin number 17 to control the spindle relay. So I said earlier that this has been partially successful. The issue really is the fact that we've got 10 volts coming from the breakout board and we want 5 volts here, and I'd put this potential divider in to divide that voltage by 2, and that doesn't really seem to be working very well. But if I measure 10 volts there, I'm getting 7 volts here, but as the voltage drops down, the PMW voltage drops down from the breakout board, what I seem to be getting here is just the same voltage as the breakout board. So not quite sure why that's doing that, and I'll have to fiddle around to sort it out. What that really means is, as you saw when I was reducing the speed of the motor, it doesn't really seem to have any effect until you get down to the point where this voltage starts going below 5 volts. So it means down to about 60 or 50% motor speed on the control, you don't actually see any change until you get to below that point, and we start seeing below 5 volts here. So yeah, I have to think about a solution there, but it's obviously not as simple as just putting a potential divider in. So this is a view of the spindle belt drive. So we have the motor here, we have an idler pulley here, and then we have the spindle drive here. So there's a lot of combinations you can use here if you have the correct size belts. With these two belts, I've basically put it down to 4 different pulley combinations. So hopefully you can see my rather scratty looking diagram. But the first 4, or should I say the first, that one and that one, are legitimate combinations, which are essentially using the idler pulley, and then the other 2 don't use the idler pulley. And you could get more combinations in between if you had some different length belts, but these are the only ones I could really work out. So the next job for the next video is to try and monitor the spindle speed. So there's a photo interrupter here that I'm probably going to replace with something a little bit more modern, with its own sort of driver circuitry in it, but I still plan to use essentially the same hardware, at least the mounting brackets. So the challenge is how we feed that back into the breakout board and monitor that in Mach 3. So I hope that was a reasonably useful overview, some of the bits and pieces I've been doing on the lathe, a bit of an overview of some of the decisions I've made on how to drive the spindles, and some of the choices of hardware, and a very brief overview of how to configure Mach 3. There are much better videos on YouTube in terms of configuring Mach 3. I'm not trying to do a tutorial here, but if you are rebuilding a similar machine, they may be able to give you a bit of inspiration and maybe a bit of direction in terms of hardware and software choices. So next time, we'll look at spindle feedback, spindle encoder, we'll look at emergency stops, and we'll look at homing switches as well, and we'll probably finish tuning the motors and just completing all the settings in Mach 3.